everyone. My name is Riya Singh and I am from KSSM College. I am in my final year in CSC and this is an internship that we have undertaken under Emergency Technologies. So this internship is about building a home automation project and these are my teammates Ranjita and Prajwal.
Good morning, everyone. My name is RANJITA GOVIND Shastri. I am pursuing my 7th sem of Computer Science and Engineering in KSSM College.
Good morning, everyone. My name is PRAJWAL Shetty. I'm in 7th SEM from CSC department, currently studying in KS School of Engineering and Management. We're glad to do this internship and Riya take over.
Coming on, so I will be explaining the introductions about the internship and further will be undertaken by my teammates. So starting off with the content. So this slides includes introduction, C programming, essentials, IoT overview and architecture, embedded system, project details and requirements, working of project along with the screenshots, conclusion, and at the end of the presentation, we will also be showing an implementation of how our project is working. So starting off with the internship. So in the introduction of this internship, so basically the internship was for a course of 1 month, and in this 1 month we have covered various topics and we've also undertaken quiz to test our understandings of the project and understand where we are going wrong and correct them and learn better. So the topics that we have covered in this internship are C programming, C++ essentials, IoT overview and architecture, embedded system, and peripherals that are required for this project, as well as the working of the project itself. Coming on to the C programming. So in C programming, we have covered a lot of topics, including the basic data types that include data types like int, float, arrays, and other data types. And then the operators that we use to manipulate the data types, change them, as well as the variables. And we have discussed about conditional constructs and looping concepts like while loop, for loop, and if-else blocks and switch cases. And then we have also discussed about advanced C concepts. And we have also discussed about pointers, the references they make, and the important addresses that we should be careful of when using pointers, as well as the preprocessor directives and header files and how they work. We've also had a short brief session about C++ essentials. And in this C++ essentials, we've learned about the OOPS concepts. We've learned about how C and C++ are different and why C is more preferred for IoT projects. We've learned about encapsulation, polymorphism, data abstractions, and inheritance in brief about each topic, as well as examples. Coming to IoT overview. So IoT basically stands for Internet of Things. And what does IoT mean? So IoT basically refers to a collective network of physical devices that are connected and a technology that helps communicate between these devices and the cloud. The cloud which acts as a storage for the device and passing on instructions to the devices. And they also facilitate the communication between the devices themselves. IoT today has become such a large thing that we use it in simple household devices like Alexa and our home automations, as well as it's become a very big industrial tool that is used to effectively create smart devices and make working much faster than before. As of today, we have more than 7 billion IoT devices in the world. An example for IoT device would be a smart home. It is a simple but the most commonly used IoT device. Coming towards the architecture of IoT. So basically architectures use sensors, actuators and smart devices, and these smart devices provide instructions and data to the gateways. The gateways send the data to the cloud gateway, which uses the control data obtained from the control applications to pre-process the data and convert it into something the user wants to do. These gateways, the control application uses data warehouses and the code of the program that we write. It's the user business logic is also placed into the control applications using the data from the data warehouse, and these these logics can be controlled by the mobile application or a web application, and all of these are used to perform data analytics to understand what can be made better. These form a very secure system and allow authentication, so which allows the user admin to only user admin to log in via the mobile applications, and does not allow anyone else to get a control over the user's devices. Coming to embedded system, so an embedded system is basically a combination of a hardware and a software, and embedded systems are usually designed to perform a very specific task. And an embedded system basically has three parts: a software, a firmware, and a hardware. So an embedded system can be built as an independent system, or it can also be used as a part of a larger system to perform a small part of the task and move on. So embedded system use peripherals like SCI, which stands for serial communication interfaces, or USBs, which we commonly which are also known as universal serial bus, and multimedia cards like your SD cards and your graphic cards, etc. So a very simple example for embedded systems would be fire alarms. Coming to our home automation project details. So our home automation project details include three main features. One is the garden lights control. So basically we are using the LEDs to perform this tasks. So in the garden lights control, we are reading the sensor value, LDR sensor value, and based on the reading of LDR, the brightness of LED is automatically varied. So basically this is supposed to resemble controlling of garden lights based on the availability of sunlight. So when there is sunlight, there is no need for garden lights to be on. So during this time, the garden lights will be turned off, and when there is no sunlight, the resistance will be high, and the garden lights will need it to be on since it is dark. Coming to the temperature control system. Temperature control system basically consists of a heating resistor, a LM35 temperature sensor, and a cooler. So basically this is supposed to resemble the temperature control system we have at our home. So we will read the temperature from the temperature sensor LM35 that we are using, and we will display it on the CLCD in our PIXM lab, and we will control the temperature of the system through the Blink IoT lab, Blink IoT mobile app. So we can turn off and on the heater and cooler at any time that we want, and if the temperature exceeds a particular limit, we can also turn off the heater automatically, so that the user can be more at convenience. Coming to the water tank inlet and outlet valve, we will read the volume of the water through the serial communication, and we will also be using the CLCD to display the volume of the water. So we can also control the volume of the water with the help of inlet and outlet valves. Outlet valve is used to let out the water, whereas the inlet valve is used to let in the water inside the tank. So we will be sending commands through the serial communication to perform this task. And then we can also turn the inlet valve off when the water tank is full, and we can turn the inlet tank on when the water tank level is very low. So this is the architecture and the flow diagram of how it will flow. So we will use the LDR sensor to read to make a guess of the sunlight available, send it to the Arduino Uno, and then use it to control the lights. Coming to the temperature control system, we will use the Arduino Uno board as our center here. And then on the Blink app, we can control the heater and cooler, and the reading of the temperature is sent to, and the notifications are sent to the Blink app. The notifications and temperatures are also sent to the CLCD for display. And the temperature system will send the temperature back to Arduino Uno, and Arduino Uno with the help of Blink app can be used to control the heater and cooler. Coming to the water tank inlet and outlet valve control. So basically again our Arduino Uno is at center here. Then the Blink app again will show the volume of the water and notifications. The CLCD is also used for the same purpose. And then the water tank is used to send the volume of the water back. And then Blink app is used to control the inlet and outlet valve, sends instructions to IoT and to the Arduino Uno, and the Arduino Uno board sends and performs the control over the water tank. These are the project requirements that will be explained by my teammate Ranjita.
Thank you, Riya. Moving towards the project requirement, we used hardware as well as software requirement in this project. Coming to the hardware requirements, Arduino UNO, Ethernet Shield, PCF8574, temperature sensor, LCD HD44780, LDR sensor, and LED. These are the hardware requirements. And moving to the software requirements, Arduino IDE, it is one of the software requirements we used in our project. It's used for coding and Pixim Lab. It's used to simulate the hardware being used. And then coming towards the virtual serial port driver. It is used to configure the ports of serial remote tank. And the last software requirement is the Blink IoT app. It is used to connect the cloud server and communicate via app. And moving towards the Arduino UNO, it is one of the software requirement we used in our project. The Arduino UNO is a microcontroller board based on the 80 Mega 324. It has 14 digital input as well as output pins, 6 analog input and a 16 megahertz ceramic resonator, USB connection and a power jack, and an ICSP header and a reset button. It contains everything needed to support the microcontroller. Simply connect it to a computer with a USB cable or power it with a AC or DC adapter or a battery to get started. It can run on both online as well as offline platform. This is the picture of Arduino UNO. And then coming towards the Ethernet shield, the W5500 chip is a hardwired TCP IP embedded Ethernet controller that enables easier internet connection for embedded system using SPI. SPI stands for the Serial Peripheral Interface. It supports the power button or power down mode and also supports for the high speed SPI. This is the picture of Ethernet shield. Then moving towards the temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and converts the input data into electric data to record, monitor or to signal the temperature changes. This is the sample picture of temperature sensor. And coming towards the LCD HD44780, this is the dot matrix liquid crystal display controller and driver LSI displays alphanumerics, Japanese Kena characters and symbols. It can be configured to drive a dot matrix liquid crystal display under the control of 4 or 8-bit microprocessor. This is the picture of LCD. And moving towards the LDR sensor, it is a photoresistor. It can be also known as light dependent resistor, that is LDR. These are light sensitive devices most oftenly used to indicate the presence or absence of the light, or it can be used to measure the light intensity. This is the sample picture of LDR sensor. And moving towards the LED. LED is nothing but a light emitting diode. It is a semiconductor diode which glows when a voltage is applied. This is the picture of light emitting diode, that is nothing but LED. Then the other topic will be explained by my teammate PRAJWAL Shetty.
We'll be going on towards the working of projects along with the screenshots. The component of the projects. Here the first the X file is loaded. The LED with a feature of on and off. Then comes cooler, heater, inlet value, outlet value, where user can control of where automatic on and off will be there. High temperature, and that means like if the temperature is very high, there will be a notification sent to the app and automatically the switching of the heater will be done. So water level full, notification and automatic switching of an inlet valve, and the next comes is the water volume level indicator. This is an overview representation when the hex file is loaded. Beside we could see a water tank where it's been water will be there loaded with then inlet and outlet Here we have used the LDR sensors, all those stuffs. So moving towards the next slide. LED on and off. The LED is turned off when the LDR is low. That means if LDR is low, the resistance is low, so LED light should be off. That means that the sunlight is present in the outside environment. In the right side of the image, where we could see that the LED is turned on when the LDR is high. That means the resistance is high, such that in the outside sunlight is not there actually. Cooler on and off. In the left side of the representation, we could see the cooler is off, cooler is on, and the right side we could see the cooler is off. Here are the representation of the components in the Arduino board. So coming to the next. Heater is on and off, same as a similar topic in the previous, as we discussed in the previous thing. In the left side, the heater is on, where in the right side, heater is off when the temperature is exceeds above 35 degrees Celsius. Then the heater is automatically turned off and send the message to the blink app. So here inlet on and off. This situation comes place when the tank is full. The inlet the it will be off and message will be sent to the blink app. Inlet valve on and off. Here the water, it controls the water level where water will be sent into the tank so that it could be filled out. Here the inlet valve is off in the given figure. This represent the outlet valve is on. So from the bottom, the water will be flowed out when the water is filled in the excess. Uh, this shows the outlet valve is off, and here we could, in the diagram we could see the water is stored in it with the outlet valve being closed. A high temperature notification and automatic switching off of an heater. In the right side we could see the temperature sensor, at which temperature it is, and we could see the notifications of the things and the cooler status and heater status. This heater is automatically turned off when a temperature exceeds 35 degrees Celsius, and we could see the notification in the which is being sent into the blink app. Here we could see the water level, full notification and automatic switching off of inlet valve. In the application, we could see the notification stating the tank is full and turning the inlet valve off. In this app, we could see all the things happening in the system. So inlet valve is automatically turned off when the water tank is full, and the notification is sent to the blink app. When the water level is low, then the tank needs to be filled. So inlet valve is automatically turned on when the water tank is less than 2000, and a notification is sent to blink app stating that the water is switched on into the tank. This is an water gauge that indicates the water level on blink app. In the application we could see how much units of water is being filled into the tank. So coming to the conclusion, this project is successfully completed using the Blink IoT app, Arduino IDE, and Pixem simulator. We have used the CLCD to display all the events, and the widgets from Blink IoT app are used to controlling the weaving the conditions of the home automation system. And here we have used the buttons such that we could control the heater, cooler, and inlet and outlet valve. The water level is shown or indicated by the gauge, and for the notification there is a text box out there where we could get to know about the status of the system. Thank you. Now we'll be moving on towards the implementation of the project will be carried out.
Thank you, Prajwal. And now we will be starting with the implementation of the project. So, like we have discussed, our project had three parts: the garden lights, the remote water tank, and the temperature control system. So, we will start with the garden lights, and the garden lights working will be explained by my teammate Prajwal Shetty.
So this garden lights, which comes within two simple concepts where LDR used when the resistance is low, that states that the sunlight is there outside, so that the LED will be turned off. So in the other case, vice versa, when the resistance is high, that means the sunlight is not there in the outside, so that is the reason where LED turns on in this situation. So this is the basic concept out there, where it is on the scale of like it resistance is used to determine whether the sunlight is present or not present.
Thank you,
Thank
Prajwal.
you.
And now I will be explaining the working of the serial remote tank. So for working of both serial remote tank and the temperature control system, we need the blink console. As you can see, this is the home automation that we are using, and the status is online, which means that our project is successfully connected to our Blink IoT mobile app. So now using the mobile app, I can turn on and off of the inlet and outlet valve. So if I turn on the outlet valve, here you can see the water is leaving the water tank. And if the as you can see, the message is shown here, and if the water tank goes less than 2000, then the inlet will automatically be turned on, as you can see here, and then the water starts filling. Now when the water tank reaches at the top, which is when the water tank is full, the, then the inlet is automatically switched off and the volume of the water is shown here. So this is it for the working of the serial tank. And as we have already included in the screenshots earlier, we get a message notification when the water level is too high or too low, so that we know when and how we can control the water tank on the Blink IoT app. Now, the working of the temperature control system will be explained by my friend Ranjita.
Yeah. The temperature control system consists of a heating resistor and an LM35 temperature sensor and a cooler. It can resemble the temperature control system at the home. It reads the temperature from the temperature sensor LM35 and display it on CLCD. We can turn on and off using the Blinkit mobile IoT app. As and when we turn on the cooler will start running and the message will be displayed on the CLCD. As and when we turn off the cooler using the mobile IoT app, we can see the message on the CLCD as cooler is off. The same concept can be applied to the heater also. As and when we on the heater, the temperature will start increasing and the message will be displayed on the CLCD. And using Blinkit IoT mobile app, we can off the heater. This is all about the working process of our project. Successfully, we completed our project with your guidance. So, thank you for this opportunity and thank you for your guidance.
We'd like to thank everybody for their opportunities at MHC to provide us this internship. And thank you to my teammates for helping towards the successful completion of this project. Thank you very much.